8.Ee.4, 8th grade, expressions and equations, number 4. So this is a very, very long standard here. Looks like we're going to be talking about scientific notation. Um, we're going to have to figure out what the difference is between a large scientific notation number or a number that is in scientific notation that's very small. And then we're going to talk, I think at the end there, a little bit about how technology might be able to use this, or an example of technology. A couple terms to know, scientific notation and what the standard form of a number is. So in your journal, I'd like you to define those two words. Scientific notation, standard form. We have a base 10 chart. I believe we've talked about this many times up to this point. If we are going in order here correctly, I'm going to quickly scoot through these base 10s. I'll start down here on the bottom with the blue ones. 10 to the 5th power means 1 with 5 zeros after it. 1, 2, 3, 4, 5. Also known as 100,000. This is 1 with 4 zeros after it, which is 10,000. 3 zeros is 1,000. This is 1 with 2 zeros, 1 with 1 zero, and 1 with 0 zeros, also known as 1. Okay, over here on the right, I know we've talked about negative exponents in the base 10, so it's just going to be the fraction form of those. We don't want to have any negative exponents, so we put it into fraction form. So this is not going to be 1 with 5 zeros, it will be 1 over 1 with 5 zeros. So that is 1/100,000th. Again, for space, I think you could figure out what I'm doing here. 10 to the negative 3rd would be 1 over 1 with 3 zeros, or 1/1000th. And let's go all the way up to the top here. 10 to the negative 1st as a fraction would be 1 over 1 with 1 zero, also known as 1/10th. You could fill in the rest of the chart for the other ones that I kind of skipped there. That's going to be important to know as we talk about the rule on this page for scientific notation. Basically, scientific notation is a shorthand way of writing numbers using powers of 10. It's taking very, very large numbers or very, very small numbers, mainly used in the world of science and technology, where you start measuring things using microscopes, etc. So there is a shorthand way. You see it here in the blue. It says some number C, whatever that number is given to us. We're going to multiply it by a power of 10, some unknown power called n. Oh boy, this is exciting. Ooh, where 1 is less than or equal to C, which is less than 10. Or in other words, whatever this C is that you see here in the middle, C must be between 1 and 10. It can be equal to 1, but it has to be less than 10. So down here on the bottom, I wrote out, okay, what must C be? Well, the capital C, or the, what is that, lowercase c, must be either 1, 2, 3, 4, 5, 6, 7, 8, or 9. It can't be 10. It can be 1, but it can't be 0. So it's got to be between 1 and 10. Like I said, it can also be equal to 1 if need be. Oh, wow. Let's try it out. We have a little chart here that has a scientific notation. It's got product form, which means we're going to have some type of multiplication form written out. and standard form, which is one of our definitions. Standard form is basically the number that we would read it as in our everyday life. We don't say numbers in our everyday life such as 3 and 2/10 multiplied by 10 to the 7th power. We just don't say that. We would have to figure out what the number is that we would say every day, and we're going to find out what that is here in a second. Product form. Product form means multiplication, so this written in product form would be 3 and 2/10 multiplied by 10 to the 7th power, which we know our base 10 chart would be 1 with how many zeros? You guessed it, 7 zeros after the 1. 1, 2, 3, 4, 5, 6, 7. Put in your commas if you'd like. We got one there, and we have one there, so pretty big number. Again, this is what scientists use. Very large numbers, it's just another way of writing it, 3 and 2/10 multiplied by 10 to the 7th. Okay, in standard form, how do we read that every day? Well, we're going to get rid of that decimal. So when multiplying by all of this 1 and all these zeros, we're basically going to bounce that decimal over to the right because this is a very large number, and whenever you take this very large number that's greater than 0 and multiply it by another number, it's going to make it quite big. So we're going to take this decimal point right here and we're going to bounce it over 7 times because the exponent is 7. So anytime we multiply by some power of 10, we are going to move it over to the right. So let's see how that's going to go. I'll do it up here, 3.2. We're going to take this decimal and we're going to bounce it 7 times to the right. 1, 2, 3, 4, 5, 6, 7, and drop it right there. Add in your zeros. All right, let's write that out. It's going to look like 3, 2 with 6 zeros. 1, 2, 3, 4, 5, 6. Put in your commas, and we would say every day that this is called, what is that, 32 million. All right, next one down. Why don't you give it a shot? Same type of problem. Pause the video. Let's see how you did. As a product form, this is 1 and 2/10 multiplied by 10 to the 8th, which is 1 with 8 zeros this time. I'm not going to put in all the commas. You can do that on your own. Over here in the standard form, I'm sure you've probably figured out that since we have to move it 8 times, we're going to add 7 zeros onto the end of the 1.2. So 1, 2, and 7 zeros. 1, 2, 3, 4, 5, 6, 7. Put in your commas. 1, 2, 3, 1, 2, 3, and there you have it. Now, in the next one, we aren't multiplying by a positive power of 10. We have the negative power of 10. So we're not multiplying by 1 with a certain amount of zeros in its entirety. We're going to have to put that into the fraction form like we did on our page over here. So we have to figure out what, where that's going to fall on our chart, one of these numbers. So let's head back there. Okay, so this one is 8 and 69/100ths multiplied by some fraction of 1 over 1 with how many zeros? We said 5 zeros. 1, 2, 3, 4, 5. Okay, I could take that as an answer, or if you want to put the fraction into decimal form, feel free to do that. You can have a decimal in there next to 8.69. Why don't I just do that for you, just so you know what I'm talking about. Okay, so 1, what is that? 1/100,000th as a decimal. Let's talk about our decimal form here. 1/100,000th. So we go tenth, hundredth, thousandth, 10,000th, and there's our 100,000th. Sorry about that position. And we add in our zeros. So let's look at that again. It would be 8 and 69 hundredths multiplied by, here's my decimal point, the 10th, the 100th, the 1,000th, the 10,000th, and here's your 100,000th position. All right, now how is that going to look on standard form? Well, we know that this is going to be a very, very small number in this case. The numbers up here are very large, but that negative exponent will crank that thing smaller. Let's see how that looks. Whoa, sorry. 8. Let's start that over here. 8.69. Move it. Now we're going to take this number and make it smaller, so we're going to move that thing to the left 5 times. 1, 2, 3, 4, 5. Drop that decimal right there. How many zeros are we looking at? Okay, so after the decimal, let's put a 0 in there too. So after the decimal, we're going to have 1, 2, 3, 4 zeros, 1, 2, 3, 4 zeros, and our 8, 6, 9. That's how we would have it in our standard form. All right, the last one on the bottom here, I made it a little trickier for you. We have the standard form of a number. We can see what position this 12 is in, or the 1, 2 here at the end. I feel like this one might be easier to go all the way back to the beginning and put it into scientific notation first, following our rules from that last page, and then determining how to write it out in product form. All right, so by rule, the number before the decimal, right over here, cannot be 0. We learned that. This number has to be 1 through 9. So anywhere between 1 and 9, and it's not, it's a 0. And if I were to move this guy over to the right, it's still 0. This guy right here looking is a 0, not good. Move it again. Move it again. The number to the left is still 0, but if I move it one more time, that number is now 1, and that was what we needed. We needed that number C to be between 1 and 9. So I would write that down as 1 2/10 multiplied by some power of 10. Now what did we do here? We know that this is a very tiny number, right? It's the decimal number. So if I moved it over 1, 2, 3, 4, I made my whole number larger. I made it 1. So I have to make up for that in my exponent as making my exponent smaller. And we know that this is a small number. I know I'm talking kind of fast. I apologize for that. But making it small means if I moved it over 1, 2, 3, 4 times, that would have to be that -4. +4 would have made that number huge. It would have been, you know, looking like one of these guys all the way up on the top here. All right, now that we know that, we could put this into product form, which is 1.2. Oh, that's awful. Come on. Got to do better than that for you guys. 1.2 multiplied by 10 to the -4th, which you remember is a fraction of 1 over 1 with 4 zeros, also known as 1/10,000th. So let's see that as a decimal. 1 2/10 multiplied by decimal. Here's my places. Here's the tenths, hundredths, thousandths, 10,000ths, and we add in our zeros. So there you have the little chart. for scientific notation, standard form, and sometimes it's good to know how it would look in the product form. It could help you out. In the standard, it says, perform operations with numbers expressed in scientific notation. So here are some operations. Our operations are adding, subtracting, multiplying, and dividing. And it looks like we're going to be multiplying here. Rule. You're going to multiply. You're going to multiply your numbers in there, your coefficients, I guess you could call them. 2.5 or 2 and 5/10 and 3. So how is that going to look? I'll do that off to the side here. So 2 and 5/10 multiplied by 3, also known as 3 and 0/10. You guys know how to do all this. Here's your 0 and your 0. Here's your placeholder. I'll use a little smiley face. I'm in a good mood today. 5 times 3 is 15. Carry the 1. And 3 times 2 is 6. With that 1 is 7. All right, let's add that up here. 5. There's your 7. And we have 2 decimals, so 1, 2. We go 1, 2. So really this is 7.5 or 7 and 5/10. 7 and 5/10. And we can, remember when we multiply common bases, our bases are 10 and 10. What can we do to those exponents? We can add those exponents up. So we have times 10 to the 6th power. Let's double check, make sure we're in scientific notation. Remember, by rule, the C has to be between 1 and 9, and this guy right here is okay. The number to the left of the decimal must be 1, 2, 3, 4, 5, 6, 7, 8, or 9, and it is 7. So we don't have to make any adjustments to this. Final answer. Times 10 to the 6th. All right, your turn, your turn. Let's go. Pause the video. All right. We have, after all your multiplication, I hope you didn't use a calculator, we have 37 and 5/10 multiplied by the same base 10. Recall, what can we do to those exponents? We could add them. So -3 added to 8 is 5. Don't stop there. I am telling you, don't stop there. Always check your final answer in scientific notation and make sure it's following that rule that we had. And I see right here that that C value is incorrect. And here's where it might get a little confusing. I have to make an adjustment to this. So the only way that I can adjust this is by taking my decimal point and moving it to the place where I would need it, and that has to follow my rule. So right now the number before the decimal is 37, and I need it to be smaller than 37, between 1 and 9. So I'm going to bounce that thing one time over to the left, because now that 3 follows my rule. So I have 3 and 75/100 multiplied by, okay, now stop there. We can't have that same power of 10 because we adjusted the first number. So what did we do? We made 37.5 smaller into 3. So we took a 37 and made it into a 3. So that is taking a large number, making it smaller. So I'm going to have to take that exponent and make it bigger. Well, how many times did I move that decimal point? I moved it 1 time. So I'm going to have to make this exponent 5 1 time bigger, and I make it into a 6th power. And that is finally written in scientific notation. That was a little tougher. I will be covering a lot more of those in class with you. Making the alterations to the decimal and the exponents is a little tricky, and I don't want to leave you out on your own there. All right, now we are adding here. It says perform operations with the numbers. Now we're going to do the addition portion of this. Now this is different than multiplying. We know that adding and subtracting is different than multiplying and dividing, so we're going to have a different idea here. Couple different ways you can do it. You could probably just figure it out mathematically on a piece of paper. Your exponents are pretty small. I'll do that first with you, and then I'll show you, if I have time here, a little different method. But 3 multiplied by 10 squared would be 3 multiplied by 100, which is equal to 300. And we're going to add to that. Let's just add to that. 6 5/10 multiplied by 10 to the 4th would be moving that decimal 4 times to the right. As we know, we're going to change the look of this. So this would be 65 with, I believe, 3 zeros at the end, because remember, you're going to move it 1, 2, 3, 4 times. So that's 65,000. And what is that equal to? That is equal to, let's put that down here too, 65,000 added to 300 would be 65,300. All right, now, if the exponents are a little tougher in future problems, I learned a little different way of doing this. You have to have your exponent, when you're adding, you have to have your exponents be the same. And one of them has the second power and one of them has the fourth. So let's make an alteration to the first one, 3, and make it have to the 4th power. Well, if I'm going to increase my exponent from 2 to 4, I'm going to have to decrease my 3 and make it smaller. So if I have to move my decimal 2 times to the left to make it smaller, I'm going to end up with 0.03 times 10 to the 4th plus, and I'm going to keep this one the same because now they're both 10 to the 4th. So let's double check. I took my second power, I turned this into 10,000, that would be 1 with 4 zeros, and I had to, if I made this bigger, I had to decrease the size of this 2 places, so I took my 3 and I moved it to the left 2 times. And let's see how that looks now. I have 6 5/10 added to 0.03, and let's add a 0 there, and here we have 6.53 times 10 to the 4th, and let's see if that is 65,300. So let's move it over 1, 2, 3, 4 times to the right. Here's my 5, here's my 3, and I plug in my zeros. And as you can see, doing it both ways, you end up with 65,300. Second way is a lot more difficult, but again, sometimes it's going to be needed when your exponents aren't so easy to work with like it was over here. That's a great arrow. Look at that arrow. All right, the last one in the standard says, how are we going to use this using technology? I just found a problem out of the book here talking about computer chips and seeing that they can be as small as, oh, look at that long decimal, meters long, and they want us to write it in scientific notation. So we know the rules to that. Looking at the number before the decimal right here, it is not 1 through 9. So we're going to have to bounce that decimal. How many are there? 1, 2, 3, 4, 5, 6 zeros. 3, 4, 5, 6 zeros. Oh, 6 zeros, and then a 5. All right, let's do our bounce. If you were in the class right now, I'm actually bouncing like a bunny rabbit. You can't see it, but here we go. We're going to bounce 1, 2, 3, 4, 5, 6, 7 times. So now we have 5 multiplied by some power of 10. Well, we know that this is a tiny number that we began with, and we went 1, 2, 3, 4, 5, 6, 7 times, so that would be to the -7th. In your journal, define the given terms that I gave you. As always, write a few sentences on what you've learned from this video. And in addition, today I would like you to go hunt down a scientific notation example that could be generated by or with technology, and give me an example and solve it so that I can see you understand what we're doing here with this.